So, we're talking about moles and how do we go from something I can see, grams, to something I can't see, atoms, okay? Or vice versa. So remember, if I have grams and I'm trying to go to something I can't see, atoms, I have to go through my bridge. It has to give me something to help me transform. You know, think about like Ant-Man or whatever analogy you want. I have to be able to transform from being visible to not being invisible, something I can't see with my naked eye. And so my bridge is my mole. Okay, so refresh. Remember we said if I'm going from moles to atoms, so that's Avogadro's number. Grams to moles, this is a mass, so kind of help you to think about it. If this is a mass, something I could physically weigh, then the number that's going to help me is an atomic mass. So this is my atomic mass from my periodic table. Now, another thing that we want to talk about is different names for masses. So far you've seen AMU, and we've talked about atomic mass as terms. So we said AMU, atomic mass units, and this was in our isotope problem. We had AMU units. But there's going to be another name for mass. Another name for mass is when I'm relating my grams to my moles. Okay? So if I'm relating grams to moles, this is going to be called my molar mass. Okay? So grams to moles is my molar mass. These two numbers are both the number off the periodic table. So I know this seems like, why do I have two names for the same number? So if you go on the periodic table, you look under carbon, it's 12.01. It's 12.01 AMUs or 12.01 grams per mole. It's the same thing. The only reason we might use one unit over the other is just depending on what we're doing. If we're doing like an isotope calculation, or if we're trying to do a conversion between grams and moles, we want to put it in grams per mole. Okay? So that's just the difference. So if you see atomic mass or molar mass, we're just talking about, are we trying to deal with them as atoms, as isotopes, or are we trying to talk about it from a moles standpoint? Okay? But it's the same number. So if you go for carbon, carbon is 12.01 AMUs, or carbon is 12.01 grams per mole. Same thing. Okay? Now, one thing I want to kind of show you in a chart is that this number depends on the element. So if I change the element, this conversion is different, where this number is the same every time. So here I kind of want to show you that. So if I'm trying to find 1 mole of hydrogen, this is the number off the periodic table, okay, in my AMUs. But you see that number on the periodic table changes based on my element. But the amount of atoms doesn't change for 1 mole because this is Avogadro's number. So if I have 1 mole of something, the number of atoms doesn't change, but the mass will change. So the idea here is, if I go back to this number always stays the same. This number changes based on what it is that I'm studying. What element am I looking at? All right, so let's do another problem. Okay? And you're going to have plenty of practice with this. So this says calculate the moles of carbon in 0.0265 grams of pencil lead. So let's ask our questions. What am I looking for? Looking for moles of carbon. Okay? And you can write out the word carbon if you want. Moles is just a shorthand. I forgot to mention that earlier. So if you were to write out grams, you would say grams. The shorthand for grams is a G. You could write out moles. The shorthand is just MOL. It's not that short, but that's the difference. Grams is just a G, moles is just MOL. So you can write out moles and carbon, but I'm going to use the symbols so you get practice seeing what the symbol is for carbon. So I'm trying to find the moles of carbon. What did they give me? They gave me 0.0265 grams of pencil lead. Now, a pencil isn't made out of lead like the element lead. So remember, pencil lead is graphite, which is a amorphous solid, which is carbon. Okay? So I've got moles of carbon. I'm looking for moles of carbon. I have grams of carbon. So we'll think through, okay, I have something I could physically weigh. I'm trying to get to moles, okay? So I have grams, and I'm trying to get to moles, and I know my mole as my bridge. Okay, so this is only one step, okay? Grams to my bridge. I'm not trying to go all the way to something I can't see. So I'm just trying to go to my bridge. So this is my one side, my one step. So this is where I have to say, okay, well, what was this one step? So this was the mass from the periodic table. So look at your periodic table. Here, I'll show you. Let me find the periodic table in this book. Here it is. All right. So if we look at our periodic table, okay, so we're talking about carbon. So it's right here. And so underneath the number for carbon is your mass. Okay, each one has a different one. So we say, that book was dirty, got my shirt all dirty. All right, so we look on the periodic table and we find the number. So the number on carbon was 12.01. But you have to remember what the units mean. It's 12.01 grams per mole. Another way that you can write this is 12.01 grams per 1 mole. However you want to visually see it. Okay? So you have to know this, and then you have to be able to go to your periodic table to find this. All right, so let's do our math. So I got grams of carbon. I want grams to cancel, so grams of carbon go on the bottom. Trying to get to moles of carbon. The only thing I have that relates grams per mole is my mass. So I go find it from the periodic table. Grams was 12.01. So my 12.01 goes on the bottom. My 1 goes on the top. Grams cancel. And I get 2.21 times 10 to the negative 3 moles of carbon. So 2.21 times 10 to the negative 3 moles of carbon. So then you say, okay, is this number right? How do I know if it's in the right ballpark or not? So moles are all going to kind of hover around 1. So they might be a little less than 1, or they might be a little bit bigger than 1. But they're not going to be like 10 to the 20 something. So if you get 10 to the 20 something moles, then that means you used Avogadro's number here when you should have used the mass. Okay? So remember, your moles is always going to hover around 1, and your atoms number is always 10 to the 20 something. So if you keep that in mind, when you get your answer, you can go, yeah, that's hovering around 1, a little bit bigger, a little bit less. This is a little bit less, so I'm okay. And when we talk about hovering, I mean, think about like, here's 1, and then 6.022 times 10 to the 24 is way over here, really, really big. So if this being just like negative 3, it's not that much compared to 10 to the positive 24. All right, so now we've done one side, okay? So we're gonna do our last problem, and then we'll be done. Now we're gonna try to put it all together and try to cross the whole bridge. So this says how many copper atoms are in a penny weighing 3.10 grams. So what am I looking for? I'm looking for the number of atoms of copper. So I want to know how much copper I have. Okay, what do I have? I have 3.10 grams of a penny. And a penny is pretty much copper. Okay? So I got grams of copper. So then in your head you say, okay, I've got grams. That's something I can hold. I can physically hold. I can weigh. I can do that. 2 atoms, which is something I can't see. So I have grams, and I'm trying to get to atoms. I can see grams, I can't see atoms. So the only way that I could go from something I can see to something I can't is to have to go through the mole. So that's where you write this down. You write your kind of like, okay, grams, moles. So then you go, okay, how do I go through my mole to my atoms? So you say, okay, grams is something I can weigh. It's a mass. Oh, this is a mass. So this is the mass from the periodic table. You just have to remember this. Okay? This side, moles to atoms. I'm trying to go to something I can't see. It's in atoms. Oh, it starts with an A. Avogadro. So you want to be able to write out this little bridge diagram off the top of your head. All right. So now let's get my info. So this is the mass on the periodic table. So I have to know what element I'm looking at. So it's copper. So I grab my book, flip to my periodic table. This is why you have to know the symbols. Go to copper. It's right here. We're going to talk about what this is called. This is called transition element. Go to copper and you get that number right there. So 63.546. So 63.55, and that's grams per mole. Depending on which periodic table, you might have 2 decimals or 3. It's okay. Then we write Avogadro's number, 6.022 times 10 to the 23rd. All right, now we can do our math, because we know it's going to be 2 steps, and these are my conversions. That's conversion 1, that's conversion 2. So let's do it. 3.10 grams of copper. Okay, I have grams of copper. I can't go straight to moles. To atoms. I have to go through my mole. Moles of copper. What relates grams and moles? My mass. 63.55 goes with the grams, so it goes on the bottom. 1 goes on top. Grams of copper cancel. Now I have moles. I don't want moles, so moles go on the bottom. Atoms go on top. What relates my moles and my atoms? Avogadro's number. The Avogadro, the A in Avogadro goes with the atoms. So this number goes with my atoms, and 1 mole, a 1 goes with my mole. So it's 1 mole and 6.022 times 10 to the 23rd atoms. Okay, so 3.1 times 6.022 times 10 to the 23rd, put in parentheses, divided by 63.55. And that's going to give you 2.94 times 10 to the 22nd atoms of copper. So now we do the exact same thing we did last time. We say, well, does this make sense? Is this correct? Is it in the right range? Well, I'm looking for atoms, and this is 10 to the 20-something. So if I have atoms, and this is 10 to the 20-something, and it's a positive 20-something, I'm happy with it. Okay? So now we went from grams to atoms. You could do the exact same thing, but go the opposite way. You go the opposite way, you use the same numbers, they're just going to be, one's going to be on top and one's going to be on the bottom. But write your units and just cancel things out. All right? So that is the end of chapter 1, and now you have covered the most important topic in chemistry, the mole, our bridge, helping us to go from something we could physically weigh to something that I can't see. All right, so great job finishing this chapter, and we'll start with the next lecture, starting chapter 2, which is going to be talking a lot about stuff that we can't see. So we're going to start into the quantum mechanics of chemistry.